Good morning, everyone, and thanks for attending to my presentation. Today, I'm going to talk about how to implement these ancestor discovery methods in the US dairy cattle database. As we know, genomics evaluations have improved plant and animal breeding because it allows us to estimate more accurately the genetic potential of individuals. In that way, we can select better parents for the next generations. These genetic and genomic estimations rely heavily on having complete and accurate pedigree information. As we know, pedigrees always have errors and missing information. So, the confirmation, discovery, and correction of relationships will allow us to have more complete pedigrees, to increase the number of usable phenotypic records, and also to increase the accuracy of the predictions. So, with the number of genotypes growing by day, nowadays there are more than 4 million genotypes in the database. We need optimized tools to detect and fill in all this missing information. Now, each animal entering the US dairy cattle database is checked for dam and sire by counting the opposite homozygotes against all the animals in the database. After that, the Mendelian conflicts are resolved and all genotypes are imputed to 80,000 SNPs. These numbers are from last year, but as we can see, the proportion of validated sires and dams is different. Almost 90% of the animals in the database are cows. Less than 80% had a sire confirmation, and only around 30% of them had a dam confirmation. The number of genotypes entered in the database without pedigree information has grown over the last year, mainly because there is an increase of genotypes coming from many different countries. Finally, 80% of the calves entering the database with no pedigree information received a sire suggestion, but only 18 of those received a dam suggestion. Therefore, we have many animals with missing information. FixPed is a program developed to detect relatives and uses haplotypes to confirm or discover a calf distant relative, which are highly likely to exist in the database. Those are maternal grandsires and maternal great-grandsires, for example. In that way, these calves with unknown maternal ancestors can now be linked with their relatives in the database. This haplotype method has improved efficiency compared with the individual SNP method because haplotype imputation allows more loci and more relatives to contribute by counting the haplotypes in common instead of only counting individual SNP conflicts. This is a graphic representation of one chromosome to show how FixPed work. Haplotypes in one individual are evaluated by dividing each chromosome into 150 SNPs windows. In order to find the maternal contribution, once the genotype sire is confirmed or discovered in the database, the paternal haplotype is then removed from the calf genotype and a match is declared if the maternal haplotype matches either of the two maternal grandsire haplotypes. And then this process is repeated again for the next generation to look for the maternal great-grandsires. The accuracy of ancestor discovery is really high, and it's very high if the true ancestor is genotype. It's also very high when the reported pedigree is wrong. If we move to lower density chips, for example 3000 SNP panels, the accuracy is slightly reduced. And finally, we have developed new features in FixPet that allow us to discover and confirm close relatives such as sire, terms, full and half sibs, clones, and paternal grandsires also. The discovered relatives, such as grandsires and great-grandsires, have been reported to the breed associations and also to the genotype requesters in many cases. But these were never used before because there wasn't a dam or even two generations of information was missing, and it was impossible to link the discovered ancestors to the calf. So after FixPet finds the ancestors in the database, a second program called FindDam creates a virtual dam or maternal grand dam ID, we also call it constructed IDs, to link these calves to their ancestors in the database. We found more than 300,000 animals with no dam information that can be now linked to their discovered grandsires and great-grandsires by creating these constructed IDs to fill this missing information. So how is the constructed ID? It consists in four parts. First, a two-letter breed code, then a three-letter country code, so each country can construct their own IDs, then a three-letter code for the ancestor, in this case DAM for DAM or MGD for maternal grand dam, and finally the numeric sequential calf ID, which is basically the animal key. This numeric part of the calf is to ensure the stability of the data processing through all the programs in the evaluations, and also can be expanded to 9 digits in the next few years. Always, before creating a virtual ID, the first step is to check if the true dam can be discovered in the same herd, and we found almost 34,000 of those. We also found around 60,000 grandsires and great-grandsires which were not previously added because their dam and maternal grand dam IDs were already reported. This paper, I wanted to show it to you, went out early this year in Journal of Dairy Science, and there we show the impact of the ancestor discovery in the genetic and genomic evaluations. As expected, the genetic reliabilities for yield trait increased around 6% points in average, and the genomic reliabilities increased around 1% point in average. This was for milk, fat, and protein yield. As a summary, we can say that linking these disconnected animals, calves, with the rest of the pedigree improved the genetic and genomic estimations. Also, identifying early pedigree errors can help us to make better decisions regarding mating, especially to avoid inbreeding. The implementation of FixPet can increase the speed of genotype loading and avoid processing delays, especially near deadlines, so the current uploading program can then only confirm if the reported ancestors are correct and avoid searching the whole database for relatives. Using FindDam, we can provide the discovered ancestors quickly, and having quick access to complete pedigrees can assure the accuracy and consistency of the genomic and the pedigree data. When a real dam ID is found outside the database, those IDs will be preferred over the constructed IDs, unless the reported dam or maternal grand dam don't match the genotype of the calf and the grandsire. Finally, the pedigree providers will have an option to remove the discovered relationships that they believe to be incorrect. With that, I would like to acknowledge our partners and sponsors, and I would like to take any questions if you have. Thank you very much.